And for every atom, there are sort of different makeups you can have for the nucleus, and that's purely because you can have a different number of neutrons in the nucleus. So if I added more neutrons to this nucleus, it would be a different isotope of this atom. So an isotope is just a different number of neutrons for the nucleus you have of a particular atom. So an example of this is the oxygen atom. The oxygen atom tends to have mostly 16 particles in the nucleus, so I think that's 8 protons, 8 neutrons. But occasionally you get one with an extra neutron or 2 extra neutrons, and so you have different isotopes of oxygen. And the oxygen isotope is actually pretty popular for scientists to look at different rocks and stuff. So scientists can make a graph of the number of oxygen 18 atoms versus the number of oxygen 17 atoms in a rock. And they find that these rocks tend to lie on particular places on this graph. So the Earth and Moon tend to lie on this line. In fact, this is evidence that the Earth and Moon actually have a common origin, probably formed from the same stuff. Mars is up here. So depending on where you lie in the graph, it just means you have different abundances of different isotopes, but in general you tend to have the same slope. Although that's not always the case, because various types of meteorites tend to fall in different places on this graph. So if the meteorites came from the Earth and Moon, they would be here. But because they seem to have different abundances and different ways of acting, they actually come from some other place besides the Earth. So that's how we know they're not actually from Earth. So this basically confirms theories that asteroids or meteorites and the stuff we get from space have a common origin in what we call the solar nebula. So at the beginning of the solar system, the sun condensed from a big cloud of gas. And in that gas was mostly hydrogen and helium, but of course the other stuff, what we call metals. And those metals kind of congealed to form what we call planetesimals. So probably some dust and then planetesimals, which are these little rocks that then collide together and eventually form planets. So if we were to look back in time, first we would have this big cloud of gas and it condenses, and then the sun's looking pretty well defined, and then we have some rocks, and eventually they all stick together and start forming planets. This is still a very active area of research. This is a very general, broad picture of what you might expect, so it's a little glossed over. But in general, that's what scientists think happens. So a lot of the meteorites that we see, we expect to come from the solar nebula. However, it's been found that a lot of meteorites contain little grains with other types of isotopes. And when you look at these isotopes and their abundances and how concentrated they are, you realize this doesn't seem like it came from the regular solar nebula. These isotopes are only things that we see coming from supernovae and other more massive stars. So supernova, if you've never heard of it, is basically what happens when a big massive star, maybe about 10 times the mass of the sun, basically collapses on itself and explodes. So this up here is a picture of the Crab Nebula, and the Crab Nebula is a remnant of what happened to a massive star. It became a supernova. So that supernova basically blows up and can create a lot of stuff that the regular solar processes can't create, including isotopes of xenon and neon. And then it kind of distributes it out through space. So scientists think that at some point the solar nebula was enriched with supernova dust and other metals. And then this is just a picture of a red giant star, because other more massive stars can form isotopes and other products that we don't see normally coming from the sun. So we think these things have enriched the solar material. So now I'm going to talk about my favorite subject, finally, micrometeorites. I think they're really interesting because they can come from a variety of places that not regular meteorites can come from. So this is a little micrometeorite. So they can come from basically a few processes. One of them is that when a meteor enters the Earth's atmosphere, it encounters a lot of friction. Friction is basically heat from like rubbing. So all those air particles are rubbing against the outside of the meteor, and it'll cause the outer edges of the meteor to vaporize or just basically melt off. Something that I learned that I think is really interesting is that actually because these meteors are going so fast through the Earth's atmosphere that if they hit the ground as a meteorite, they're actually very cool to the touch, unless they're very good at conducting heat, but for the most part they're not. So if you see a meteor, if you see a shooting star, and then you somehow rush to the place that you saw it, and you found a rock that was cool to the touch, that is the meteorite. So anyways, these meteorites or meteors can vaporize, and they produce little tiny particles that congeal in the atmosphere and then fall as micrometeorites. Another way you can get micrometeorites is basically from vaporized bits of material from impacts. So this is Meteor Crater in Arizona. I think it's about a mile wide. Meteor Crater, actually, if you went around and searched and sifted through all the dirt, you could find tons of little pieces of meteorites. And that's basically from the melted parts or the vaporized parts of the meteor that made this crater. And you could probably find some all around here as well, because it would create a big cloud potentially and then like settle back down. And in fact, this person, his name is Harvey, I don't know how to say his name, Nininger, I think, or Nininger. And he basically set up a museum near Meteor Crater. He was very much obsessed with meteorites. And he went and collected dirt from this area and found tons of itty-bitty beads, which were meteorites or just melted stuff from the initial impact. So another way you can get micrometeorites is basically in the form of what they call interplanetary dust particles, IDPs, or interstellar dust particles, which I realize has the same acronym, so I didn't write it down. But I thought it was really cool when I found out that the way people research this stuff, because for the most part, for really small dust particles, they can enter the Earth's atmosphere and float down kind of like snow almost, without being melted or vaporized. And they'll hit the ground and they'll look kind of like this. But the other way you can find particles like this is to go up into the upper atmosphere using an old spy plane. So people use this old UT spy plane, and basically they fly it, I think it's about 20 kilometers above the surface of the Earth. And they'll, as soon as they get up there, they put out these panels that are covered with like an oily stuff. And so dust particles that are continuously raining down on the Earth will fall and stick to the oily stuff, and then they kind of bring it back in and they land and they take away the oil, and they find tons of little grains that must have come from outer space. And this is what they look like. This is under a scanning electron microscope. But just for scale, this one is 1 micrometer, which means maybe it's 10 of those. So it's about 0.01 millimeters. It's really tiny. So anyways, they look fluffy. I think that's great. So the kind that you will find with the method I'm about to tell you about are actually probably this. This is just my guess. And you'll see in a second why I think that is. So how do you go meteorite hunting in your own backyard? It's actually surprisingly easy and really fun. All you need is a strong magnet. Like the refrigerator magnet doesn't necessarily cut it. You probably want to get something from like a fun science kit. Plastic wrap, easy to find at home. And something like a strong magnifying glass. And if you have a microscope at home or maybe at your school, it's even more fun because you can find smaller stuff. So those are the 3 things you need. And then I have a really terrible looking cartoon. So you have micrometeorites. They rain on you every day. Oh, by the way, I just realized this like a few days ago. In my abstract, I wrote that it was about 2 tons of micrometeorites that fall on the Earth, and I was off by 2 orders of magnitude. It's actually like 200 tons of micrometeorites that is estimated to fall on the Earth every single day. And that's like itty bitty stuff. So you're like outside and you're just being covered with micrometeorites all the time. So you can go out into your backyard or whatever you have. And micrometeorites are out there. And you take your magnet. You want to cover it with plastic wrap because if you've ever used a magnet and run it through iron filings or something like that, you'll find that the iron filings are really hard to get off.